Hello, Quist Royals. Welcome to another Ed Puzzle by Mr. Burner and Miss Patterud. This one will be on matter and energy. All right, our learning target for today. I can be able to identify what is matter and what isn't, and can learn what energy is and all of the different types. Okay, so by the end of this lesson, you should know matter, conservation of matter, energy, and conservation of energy. So what you'll do, you'll follow along with this Ed puzzle. You'll answer the questions as best as you can. And what I hope that you will be able to show by the end of this lesson is an increased knowledge about matter and energy. All right, what are we waiting for? Let's get started. Hey, Mr. Burner, what's matter again? Wow, students, I'm glad you asked. Matter is anything that has mass and takes up space. Okay, so all matter is made up of different tiny little particles called atoms, which combine together to create everything that you see in the world today. Okay, matter has three different states: gas, liquid, and a solid. So, what are some things that are considered matter? Okay, so we have three states of matter: solids, liquids, and gases. So a couple examples we can pull from for solids would be like a hat, a table, a skateboard, a computer. Really any sort of solid object that you can pick up, that you can touch, that you can hold. These are all considered matter. Liquids are also considered matter. They have mass, they take up space. Hot chocolate, milk, water in a pool, rain, soup. These are all examples of matter. We can all touch them. They all take up space. They all have mass, so we can weigh them. So these would all be considered matter. Gases can be a little bit trickier. But again, we have many gases that we consider matter as well. So wind, the air that you breathe, steam from an iron or from something else, hot air balloon, these are all considered matter. Okay? So just because these things might be invisible, they might be hard to weigh, they still take up space. And as we proved in class, we can still weigh air. Okay, so even gases are considered matter. So what is not considered matter then? Because that list seems pretty comprehensive. Okay, so there are some things that are not considered matter. Okay, and most of these things that are not considered matter are considered forms of energy. So time, sound, sunlight, the reflection of a rainbow, love, thoughts, information, reflections, heat, gravity. All of these things are considered not matter because they don't take up space and they don't have mass. So I would challenge you. You cannot weigh a rainbow. As hard as you try, you cannot weigh it. Okay? Same with time, same with sound, same with sunlight. So again, these things are considered not matter because again, they do not take up space and they do not have mass. All right. So conservation of matter, what does that mean? So that basically just states that matter cannot be created or destroyed. So matter can never be created or destroyed. It only changes shape or form. Okay? So matter can transform to something new. If you were to combine baking soda and vinegar, you would form a reaction, but again, nothing would be created, nothing would be destroyed, things would only change shape. Okay? So if we look at this chemical reaction over here, the mass of the beakers and the substances inside of the beakers didn't change even when the chemicals were combined and created a new product. Okay? So that new product is still matter. It's just a different type of matter. Okay? So again, you cannot create or destroy matter. Even if you were to eat a sandwich, eat some sort of food, that food doesn't just disappear, it just changes form. Okay, and then it exits your body as waste. Okay, so the law of conservation of matter states that matter cannot be created or destroyed, it can only change shape or form. All right, let's look at some examples. Okay, number one is water boiling. When water starts to boil, some of the water at the top of the pot evaporates. However, it doesn't disappear. It just exists in a different form, and that's what we call water vapor. Okay, so as you can see, there's some steam coming out the top of the pot. So that's just the water. Okay, the water's getting hotter, it's evaporating, it's turning into a gas. But as we learned previously, gases are still forms of matter. Okay, so while this water is changing forms, it's still water, it's still a form of matter. On the other side, we have ice melting in a glass of water. Okay, so it kind of seems like from first sight that ice kind of just disappears. However, it doesn't. All right, let's take a look at this video here. Okay, so that ice is melting. Watch that water level. Is it changing? Yeah, that water level doesn't really change. It doesn't look like we added water. It doesn't look like we took away water. No, it just stays the same. That water turns into ice, which is just another form of water. Okay, so no water was created, no water was destroyed. That water just changed form. All right. Mr. Burner's favorite drink, chocolate milk. When I squirt chocolate syrup into my milk, it seems to disappear. However, it does not. Let's take a look at this exhilarating video of this person making a glass of chocolate milk, and let's watch what happens to that chocolate syrup. This person stirs and they stir and they stir and they stir until finally that chocolate syrup disappears and we have chocolate milk. Okay? However, that chocolate syrup does not actually disappear. It simply just combines with the milk to transform into a totally new thing, which is chocolate milk. Okay? So it doesn't actually disappear. No matter is created or destroyed, it just changes. All right. Let's watch this person light a piece of paper on fire. I'm sure your parents have all told you not to play with matches, but it's kind of what science is about. All right. So we can see that paper start to burn. It appears as if it's starting to get smaller, it's starting to disappear. However, if we look at all the smoke escaping from that piece of paper, we know that this piece of paper is not just disappearing. It's turning into ash, it's releasing CO2 into the air. So again, this piece of paper isn't being destroyed. This matter isn't being destroyed. It's just changing form. All right. So now that we know a little bit about matter, let's talk about energy. So energy is the one thing that makes matter move, okay? So energy can be defined as the ability to do work, or again, the thing that makes matter move. So energy exists in many different forms, and we're going to take a look at a couple of those different forms later on in this lesson, and we're going to try to be able to differentiate them. Okay? So much like matter, energy is conserved. Let's take a look at what that means. Okay, so much like matter, energy cannot be destroyed or created either. Okay, so energy exists and it often changes in form, but it cannot be created or destroyed. Okay, it only transfers, it only changes, just like matter. Okay, so if we take a look at this example on the right, when that bowling ball strikes the bowling pins, the energy is transferred from the person throwing the ball into the ball, and then the energy from the ball is then transferred to the pins, and that's what makes them fall down. Unless you're bad at bowling, but that's okay. So again, no energy is lost. Energy is simply just transferred from the ball to the pins. Okay. Our other example down here, electrical energy. When you turn on a light bulb, that energy transfers from being stored inside the wires in your home to then lighting up the lights in your home, heating up your home. So again, that energy is just changing form. Okay, let's look at example number 1. When a moving car hits a parked car and causes the parked car to move, energy is then transferred from the moving car to the parked car. Okay, so no energy is lost. It's simply just transferred. Okay, so as we can see by this truck backing up, he's got a lot of speed. All right, and this white car over here, it's not moving. Okay, but when that truck backs into that white car, he transfers the energy to the white car, and that's what makes it slam into the wall. Okay, so no energy's lost, no energy's gained. It's simply just transferred. All right, let's look at example number 2. This is for all you sports fans out there. When someone kicks a soccer ball, the energy from their body or their leg is transferred to the ball, which makes it fly into the air. Okay, so energy isn't lost. The energy is being transferred from that man's leg to the ball, and then finally into the net, which makes that net ripple. Okay, so again, is energy being created or destroyed? Nope, just being transferred. Oh, and the crowd goes wild. He's happy about it. All right. Let's look at our types of energy. So we can classify energy into 2 main categories, potential and kinetic. Okay. Potential energy is the stored energy of an object, and kinetic energy is actually the energy in motion. Okay, so the energy of a moving object. So if we look down here at our examples for potential energy, when that guy pulls his bow and arrow back, right when it's at that back position, right when he's ready to let go, that bow and arrow has stored energy that's just waiting to be released, and that's what we call potential energy. Okay? Same with that demolition machine over there on the left. That wrecking ball, it's ready to demolish something, it's ready to hit a building, it's ready to transfer its energy. Okay? But since it's not moving yet, that energy is stored and it's considered potential energy. On the other hand, you have this track star over here just running through my Google Slides presentation, and that's what we would call kinetic energy. Okay, so that's energy in motion. That's energy of something that's actually moving. Okay, so when that guy releases the bow and arrow, that arrow flies through the air. That's what we call kinetic energy, because that energy is in motion. That energy is in a moving object. Same thing with that demolition machine. When it actually swings that ball to hit a building, that's when we see kinetic energy, okay? Because it's actually moving, it's in motion. All right, we have a perfect example right here. We have this little kid over here who's holding a ball. He's standing on a building, potentially, not really too sure. But he has potential energy over on our left-hand side over here because he's got the ball in the position. He's waiting to drop it. He hasn't dropped it yet. So that energy is stored. It's potential. It's waiting to be transformed into kinetic energy when he finally releases it. So over here on the right, he drops it. He drops that ball. He's just watching it fall. Hopefully it doesn't hit anyone. So he is transforming potential energy into kinetic energy. Okay. So once he drops that ball, once that ball actually starts to move, that's when potential energy becomes kinetic energy. Okay. Because again, kinetic energy is the energy of something that's actually in motion. All right. So we can kind of break down the types of potential energy and the types of kinetic energy. Okay. So there are many, many types of energy, but I decided to include the three most common types of potential energy and the three most common types of kinetic energy. Over here, we have the types of potential energy as chemical, electrical, and nuclear. And then over on the right, our types of kinetic energy are thermal, also known as heat, and sound and light. Okay, so let's take a closer look as to what these types of energy really mean. All righty, chemical energy is a form of potential energy. So chemical energy is the energy stored in the bonds of atoms. So when atoms actually combine to create a chemical reaction, that energy is released, and that is what we call chemical energy. So if we take this chemical reaction down here at the bottom, for example, when the two substances combine, when that person pours that substance into the jar, notice what happens, okay? Chemical energy is released when the beaker starts to overflow. So when that beaker overflows, that's what we call chemical energy, okay? The energy from those atoms are releasing and they're transferring, and now we have a reaction. Electrical energy is another form of potential energy. Okay, so electrical energy is just a fancy way of saying electricity, right? So electrical energy is stored in outlets in our homes, in batteries, in our electronics. When we plug things in or we turn our electronics on, that energy is transferred from an outlet or a battery to our devices, which then power them up. Okay, so we all use electrical energy every single day, especially when we go home and we plug our Chromebooks first thing in and we get to work on our assignments because we love school so much. That's a form of electrical energy. Okay, so if we look at our example over here on the right, we have a plug, and when you plug that in, electricity is sent through that wire, and that's what powers on that stove. That's what powers on that lamp, that computer, that blender. So again, these are all examples of electrical energy, which is again a form of potential energy because it is stored in our homes and in our devices. All right, nuclear energy is our last type of potential energy. Nuclear energy is stored in atoms. Remember, atoms are those tiny, tiny things that make up all matter. When atoms combine with each other or split apart, nuclear energy is released. So if we look down here at our example, we have two atoms combining, which creates nuclear energy, which then is wired to our homes and our buildings and our cities, which helps power them up. Okay? So the reason that this is a form of potential energy is because it's stored in atoms, right? So it's waiting to release, it's waiting to combine, and then we can create nuclear energy. Okay? All right, enough about that, all that potential energy. Let's talk about kinetic. All right. So thermal or heat energy is our first form of kinetic energy. So heat energy is created by a rise in temperature. When the temperature rises, atoms and particles start to move rapidly, which causes energy to change form and become heat energy. So take this boiling pot of water, for example. Particles start to move faster as the heat energy transfers from the stovetop to the pot and then to the water. So the water starts to get hotter and boil and evaporate, and that's when that heat energy is released, and we have water vapor releasing into the air as steam. All right, sound energy is another form of kinetic energy. Sound is energy that we can hear. So it's just caused by vibrations of matter. Let's take this strumming of a guitar as an example. When the man's fingers come in contact with the strings, it causes a vibration of energy that we hear as sound. Okay? So potential energy is converted into kinetic energy when he starts to strum the guitar, and then we hear those vibrations in our ears as music. Okay? So sound is energy that we can hear. Alrighty. Our last type of kinetic energy that we're going to be discussing today is light energy. So light energy is a kind of kinetic energy with the ability to make types of light visible to human eyes. So for example, the sun, a fire, light bulbs, these all create visible light for humans through their atoms heating up. And when their atoms heat up, they create visible waves called photons, and then that's visible to the human eye. Okay? So if you've ever noticed when it's really, really hot outside, if you look across a field, a basketball court, any sort of concrete, and you see those little waves of heat, okay? That's light energy. That's visible light from atoms heating up. Okay, so on a really, really sunny day, you can see a lot of light energy. It's going to be atoms heating up and creating these visible waves called photons. Okay, so that's light energy. All right, students, that's going to wrap up today's lesson on matter and energy. So for today, you should be familiar with conservation of matter, what's matter and what isn't, energy, conservation of energy, and then the two main types of energy that we talked about, kinetic and potential, and then all of the different forms of kinetic and potential energy. That was a lot of information. So thank you for staying with me. Thank you for doing your best and paying attention and answering all the questions. And again, if you have any questions or concerns at all, if any of this information's feeling fuzzy, please feel free to reach out to your teacher, either myself or Miss Patterud, and we'd be more than happy to help you out. All right, y'all. Have a wonderful day.